Hello, and welcome to a special presentation here on LMTV. I'm Brian Hoppe, Chair of the Township's Environmental Advisory Council, or EAC. In September 2018, the EAC presented a public sustainability workshop. The discussions that evening explored various aspects of sustainability, and we hope served as a launching point for a much broader conversation about how Lower Marion can meet the needs of the present without compromising the ability of future generations to meet their own needs. Back in April 2018, the EAC presented an environmental action plan to the Board of Commissioners. The plan is ambitious, and it contains numerous initiatives that will guide the EAC's activities for the next 5 years. One of the plan's initiatives recognizes the need to increase the township's resiliency, further improve environmental quality, and develop a more holistic approach with regards to sustainability within the township. That served as a driving force to conduct the sustainability workshop. LMTV was on hand to record the workshop, and we present the first segment of the evening now, Climate Change and Its Consequences. Enjoy.
I have to say that this was always intended to be an extreme weather event. And that is that we've intended from the first to address a number of weather questions. Whether climate change is real and grounded in empirical data, whether it poses real, imminent, or merely imaginary dangers to the quality of life and environment within Lower Marion, whether climate action, such as the adoption and implementation of a greenhouse gas emission reduction strategy, should be a governmental priority on the same plane as police and fire protection, trash pickup, development, stormwater management, traffic control. Whether Lower Marion is as resilient as it can and will need to be in the face of the unavoidable consequences of climate change. Whether we can learn from the experience of industry and other municipalities about the advantages of sustainable energy planning, the political challenges that it involves, and the economic opportunities that it affords. Whether township government can and should play a role in influencing the energy decisions of the private sector. Whether the costs of climate action and resilience are exceeded ultimately by the costs of inaction. Now, the genesis of this workshop was a meeting between the Environmental Advisory Council and the Board's Environmental Initiatives Committee, at which meeting we presented our 5-year environmental action plan. One of the goals of the EAC's 5-year plan is the adoption of a greenhouse gas emission reduction plan, something that the EAC has been advocating since at least 2012. Recognizing that not everyone has the same understanding of the concepts of climate change, climate action, resilience, sustainability, it was agreed by the two bodies that the EAC should conduct a workshop to illuminate these concepts. So the purpose of the workshop, this workshop then, is to lay the factual groundwork for policymaking in general and for the board's consideration in particular of the launching of a sustainability planning process for the township. With that, why don't we just then get started? I'm delighted to then introduce the first segment of the program, which is devoted to a discussion of the science and consequences of climate change. And our speakers will be Tamar Norquist, followed by Jesse Lytle, followed by Dr. Dan Wolk. So, Tamar?
So I was thinking that I might do this standing. I think I So thank you very much, David. As my bio says, at Shipley, I teach chemistry, and I am the sustainability coordinator there. And my part of this talk tonight is to just explain the basic science of climate change. And then everybody else will talk to you about municipalities and constructs and things like that. So because I'm a chemistry teacher, I have to start this talk by telling you the definition of chemistry. Chemistry is the branch of science that studies the matter of the physical world and the changes and the energy changes that that matter undergoes. And when I think about climate change, it is exactly at the nexus of those two things. And as I always tell my students, all of us know a lot more about chemistry than you might think you know, because you've been living among the matter of the world for your entire life, and you've been making very astute observations. So one thing that you know, even though you might not realize you know it, is that different kinds of matter interact with energy in different ways. Some kinds of matter don't really interact with energy at all, or much at all. A great example of that is styrofoam, which I know might be a little bit of a touchy subject given the EAC, but if you'll forgive me. So styrofoam doesn't really absorb energy at all, which is why we pour our coffee into it, right? It doesn't absorb it, heat stays in the coffee. Other kinds of matter absorb energy but let go of it very quickly. And a great example of that is aluminum, right? It has what's called a high heat capacity, which means, and if you've ever cooked with aluminum foil, you know that you pull it out of the oven, it's hot, and then it's very quickly cool because it lets go of heat quickly. But some kinds of matter absorb energy and hold onto it really well. And a great example of that is water, which we all know because if you've ever sat in front of a hot cup of tea and tried to let it cool, you know that that takes a long time because water holds heat. And what's true of liquid water is also true of gaseous water. Water vapor also holds heat, which we all know very well because when the temperature was 92 degrees outside, which did you want? A high humidity day or a low humidity day, right? Water vapor holds heat just as much as liquid water. And the fact that water vapor is so effective at holding heat makes it what we call a greenhouse gas, which I know that everyone has heard about. The definition of a greenhouse gas is a gas that holds a lot of heat. And the issue with greenhouse gases in our environment is that the heat from the sun comes down, is absorbed, and is not let go, and we have a warming climate. Now, as I say, I know that everybody has, heard a lot about greenhouse gases, and probably anyone who's ever spoken to you about it was not talking about water vapor. They were talking about carbon dioxide. Carbon dioxide is the big one. Water vapor is a greenhouse gas, as is methane, as is nitrous oxide. But carbon dioxide is the big one. The reason I chose water is just because we all know water, we all relate to water. And that brings me to this. So this is one of my all-time favorite equations in chemistry. There are others, but this is the one I'm talking about now. So that CXHY term. Okay, so that's obviously a variable, a dummy term, and it stands for all organic compounds, organic chemistry being the enormous branch of chemistry that deals with carbon-based compounds. And within that group, for the purposes of this conversation, is a very important class of compounds called fossil fuels. Fossil fuels are all organics, and that's oil, coal, gas, wood, all that stuff. So that's your fossil fuels. And if you remember your high school chemistry, which I certainly hope you do, you might remember that plus O2 means combustion. Okay, that's burning. That's the chemical, that is what burning is. It's things chemically combined with oxygen. So this is the equation for the combustion of an organic. And this is the equation for burning fossil fuels. And as we can all see, the product side is carbon dioxide and water vapor. Okay? And that's it. When we burn fossil fuels, this is what is released. this graph shows the trend in the consumption of fossil fuels since the Industrial Revolution. I just think it speaks for itself. It's gone up in a way that could not really be fathomed very much by human thinking. And all of that is more of those products. The last thing I want to say is this. Whenever we talk about climate change, there's always this question. There is this hovering question in our world of whether it's true and whether it is human caused. So the scientific community is nearly completely agreed that the answer to those two questions is yes. And the foremost voice on this is a body called the IPCC, which is the Intergovernmental Panel on Climate Change. It's a group of the leading 1,300 climate scientists of the world. It's overseen by the UN. And 4 years ago, they put out a major study that said that they could say with upwards of 95% certainty that climate change is very much happening, and over the past 50 years, humans have had an impact on it. And as an aside, and I'm sure there are scientists in this room, scientists never say they're 100% certain of anything. It's just not what we do. So upwards of 90% certain, 95% certain is about as far as we go. So I'm here because I'm representing the scientific community. And the work that science does is to observe the world very carefully, to collect the data and to interpret that with as much accuracy and truth as we can. We believe that this is real, and we believe that humans are a big part of it. And the question now for us is what we're going to do about it. Thank you very much. I hand you off to my esteemed colleague, Jesse Lytle, to talk about that.
All right, the magic of technology. Here we go. Can we flip on the fly? Check that out. Thank you, Tamara. That was great. So my role here is to talk about the impacts of climate change. And it's a huge topic. We could talk about it for years. The impacts are global. They're huge. They are multidimensional. But we're not going to tackle that all tonight. We're here to talk about Lower Marion. So this is going to be a high-level gloss. I'll allude to many topics. I'm not going to talk about ocean acidification. We're not going to talk about forest fires because they're not sort of first-order impacts on Lower Marion. But we all know they're out there, and we would feel those things in secondary and tertiary ways. So just to give you a little confidence, you might recognize the shape of this chart. It looks a lot like Tamar's. And this is just to reiterate that we're dealing with a fossil fuel problem, and this is annual output of fossil fuels. And the fossil fuels in the air are going to stay with us for 100 to 1,000 years, some of them. So they're in the atmosphere. You might wonder what happens if we cut fossil fuel production or burning to zero now. Well, within about 20 years, half of the carbon dioxide would fall out of the atmosphere. So that's just to say that this issue is solvable if we give it time, that natural cycles can help us if we give them a chance to catch up. But what is the impact? That's what I'm here to talk about. Well, the first thing is that it's getting hot. And this is observable, verifiable. Four of the hottest years in recorded human history are the last 4 years. We might wonder in Lower Marion, is that true everywhere? Is it true for us? It is true for us too. This is our local temperature data, 1895 to 2015, and you'll see a 4-degree increase in average heat here in the Delaware Valley. We still might wonder, though, there are all these weather anomalies. We might remember in the spring, in March, we thought we were ready for spring, and it was cold. It was lousy. So how does that happen, that the climate is warming, but we're still having these cold days? And sometimes we have, we have spectacles like Congress people walking into, the Capitol with snowballs in their hands saying, see, there is no global warming. So let's just get into this data a little bit. This is our average summer temperatures from 1951 to 1980. It's a classic bell curve. So the white are the days in the middle, pretty average, and then we've got some standard deviations of cold, standard deviations of hot. And the important thing to remember here, as we look at this baseline, is that the human race and our society is really well adapted to the mean, what normally happens, and maybe a standard deviation or two to one side or the other. We thrive in that, right? We've made incredible progress. Once we get outside of that, things get a little shakier. So over time, let's watch what happens to our bell curve. This is 1983 through 93, and you'll see that temperatures have shifted. We're getting hotter on average. We still have plenty of cold days, but we have more hot days, and we have a tail now on the right side of really hot days. That's 4 to 5 standard deviations out. Another decade, and we shift even farther, and another decade, we shift even farther. Now remember that band in the middle from 1950 to 1980 when we thought, we're really good at living in the mean and close to the mean. Well, most of our world now is outside of that mean and standard deviations away. And we feel that stress all the time. It's stressing our systems. You might remember late August when it was so hot. Things just weren't happening. Outside work sites couldn't convene. If you're a tennis fan, you saw Roger Federer crack. I mean, that's crazy stuff. The upshot is, here in Metro Philadelphia, by the end of the century, it's going to feel more like southern Texas, climatically. This is just based on the carbon that's already in the atmosphere. This is not if. This is where we're heading. What happens when it gets hot? Well, again, when we step outside of our standard deviations, the world we've built does not react the way we want it to. It got so hot in Oaks that this road buckled in the heat, and that's just an example of how our infrastructure wasn't meant to deal with these extremes. Human beings were not meant to deal with these extremes. This person was suffering from heat exhaustion. She ended up being okay. Dr. Wolk will be talking more about the impact of climate change on human health. As Tamara alluded, water holds heat really well, and this is important as we think about the effects of climate change, even here in Lower Marion. So most of the heat from climate change is going into the oceans. Why does that matter? Well, one reason that matters is because of storms. And we've seen Florence in the news, and we could show the same imagery with Florence. This is a post-mortem on Harvey. So you remember how devastating Harvey was. Harvey crossed a Gulf of Mexico that was 7 degrees hotter than normal. Hot water means that there's more precipitation, higher wind speed, and a larger storm surge with every storm. So that's just happening. And this is what Houston looked like because they built a city based on the mean, the average, what you're used to. And when the rainfall was outside of that average, they could not take it. We can say, phew, thank goodness we're not in the hurricane belt in the Gulf of Mexico, but we're not safe from it. You might remember Hurricane Irene hit Philadelphia in 2011, and this is what our downtown of Center City looked like. And this is indicative of what will happen. Again, not if, but when. Cyclonic storms don't only come in the form of hurricanes, they also are nor'easters. And again, a crazy March, we had 4 nor'easters. So I work at Haverford College. We had to shut the college down for a few days. If you have school kids, you probably kept them home for a while. It was really disruptive. Caused a lot of damage. 2 of those storms cost over $1 billion in the Northeast. We're actually in the crosshairs here. So if you look at how heavy downpours and heavy precipitation events are increasing nationally, the Northeast is getting the worst of it because we're getting weather coming across the country from the Great Lakes, we're getting weather coming up the coast, we're getting nor'easters off the ocean. So we have more downpours here than anywhere else. And even looking inside Pennsylvania, in Metro Philadelphia, we are way worse off than even nearby Lancaster or Harrisburg. Now this matters a lot, actually. I mean, as we saw today with this heavy downpours, they cause erosion, they cause damage, and they don't replenish the aquifer either, right? The water just rushes off the land back into the river or the ocean, and you don't get the benefit to farmlands or the public water supply. And you get scenes like this in Bryn Mawr. This was not today. You get scenes like this in Ardmore as the soil gets saturated. Now, we could talk a lot about precipitation. The same phenomena that leads to all that precipitation, namely the heat drawing moisture out of the oceans and creating rain, actually leads to drought by drawing the moisture out of land. And we feel that here in Pennsylvania. We're losing our snow coverage. We will probably see 60% less snow coverage in the state by the middle of the century. We're seeing droughts. So as nearby as Lancaster County in central Pennsylvania, over the past few years, we've had drought emergencies where the state government has had to step in. We haven't been able to have local produce. The farmers there are hurting. As temperatures rise, water use, of course, does too. So this is the cruel, vicious cycle, right? As we have more heat and less water, we need more of it. The Delaware River Basin provides water to about 15 million people. And this is a chart of the salt line. So that's how far the salt from the Atlantic Ocean creeps up the river because of tides and water levels. The little purple line there is where it normally is outside of Wilmington. In a drought, it can go up to that red line. And up at the number 110, that's where the city of Philadelphia pulls water in to drink. So as we get droughts on land, there's less water flowing into the basin, down the river, supplying fresh drinking water to our region. This is a map of the world showing where the warming is happening from the Industrial Revolution till today. So I want you to just mind the patterns and where the heat happens. Right, so that's what it was in 1880. Here's where it was by 2016. So obviously, mostly in the north. The problem with that is that's where most of the water, or much of the water of the world, is locked up in ice. So you have glaciers like this in 1935 that look like this more recently. Where does that water go? Obviously, it goes into the oceans. Now, again, in Lower Marion, we're okay. Our coastline is not a Lower Marion issue, but it's part of our region, and so we need to be mindful of it. And we know that our whole region is vulnerable. If you spend time on the shore, you'll remember Superstorm Sandy, exemplary of what will happen as water levels rise and storms continue. It also affects the salt line, right? As the ocean gets higher, the salt water will push up and up and up. So between drought and ocean level rise, drinking water supply in our area is going to be more and more stressed. Now that's a lot of dire stuff, and you might wonder if the scientific community is trying to over-catastrophize this. This data is actually from the insurance industry, because at the end of the day, when we have disasters, they get paid for most of the time. And the insurance industry is the one that takes the brunt of it. And so this is a catalog of the extreme weather catastrophes that have happened over the last 30 years or so. Obviously, the trend is up. Last year, the total dollar value of damage because of severe weather in the United States was over $300 billion. That's a huge number. And of that, 38% was insured, 62% of that was uninsured. That means the tab is picked up by homeowners, businesses, schools, municipalities. So this is something we have to watch. Another effect of climate change is that habitat is changing, right? It gets warmer, animals can thrive elsewhere. So this is just an example with one species, the Aedes aegypti, which is a certain kind of mosquito. It carries the Zika virus and unfortunately is now comfortable in the mid-Atlantic region. What's interesting is that land species are on average moving poleward about 15 feet a day. So ticks are more and more comfortable where we are. Trees are less comfortable where we are, or at least the trees we're used to. So many of the sort of heritage trees that we think of as defining Pennsylvania and our community actually are not going to thrive by the end of the century. And we're starting to see that. My employer, Haverford College, is an arboretum, and a lot of the tree species we planted aren't thriving so much anymore. And just over time, they get weaker and weaker, and between that and storms, you see more and more trees coming down. And this is just a reality that our community is going to face as we think about our landscape. Climate change is affecting our food supply. I'm not going to go deep into this, but just make a mental note that we need to be aware of this. It's a whole network of factors that combine to affect, in particular, our staple crops, which together make up about 2/3 of human caloric intake. So with every degree of rising, there's more and more stress on the world food supply. More locally, Pennsylvania agriculture will be suffering from a combination of these issues, including pests, invasive plants, and we're going to need more chemicals to deal with that in order to keep feeding our growing population. Dairy farmers will be feeling the heat. Cows don't like heat. Production goes down. Milk will get more expensive. It's just one sort of example among many. I'm going to let Dan talk about health, but this is just a preview of the many factors involved. Just in closing, I'd like to think about the total cost of carbon. So David at the beginning asked, is action or inaction more expensive? Well, right now, climate change is considered the #1 threat to the global economy for all the reasons we've discussed and many more. And the financial system and the world government is starting to really bear down on this. So the G20 has a task force. It's creating a new voluntary climate-related financial disclosure process. And what this means, this sounds pretty technocratic, but if you have an organization and you have investors, you're going to have to get your head around what your exposure is from climate change. Nobody's going to want to invest in a business, a municipality, if they think their investment isn't safe. And Moody's is taking the lead on this, incorporating climate risk into their rating systems. So obviously there are many directions this is coming from. I'm going to stop there because there's a lot to talk about, and we can go back to any specifics during the panel discussion.
Thank you for joining me as we present the Environmental Advisory Council's Sustainability Workshop. We'll be back next time with more from the evening's presentations. In the meantime, you can view the workshop in its entirety online. I'd like to thank EAC member David Richmond and one of the township's senior planners, Andrea Campisi, for all their work in organizing the event. I'm Brian Hoppy, Chair of the EAC. We'll see you next time.